Good morning, Mr. This is here in another one. Today we're going to look at another property of circles. Remember, we have been working on property of circle. Today we're going to look at secant and a tangent. All right? And when you have a secant and a tangent that share an external point, which is a point that is outside of the circle. And the theorem stated that if a secant and a tangent segment share an endpoint outside a circle, then the product of the length of the secant segment and the length of its external segment equal the square of the length of the tangent segment. So let's try to break this out. Let's try to clarify that. It looks like Chinese, so that's how math is. The theorem looks like Chinese, so as a teacher you have to come and break it down. All right, in this case, what they're telling you, if you have a tangent and a secant, so you're going to take the tangent, whatever the tangent is. In this case, EA is the tangent. They tell you you're going to square AE. Whatever the expression of AE is, you're going to square EA, and it's going to be equal to external part of the secant, which is EC, times the entire secant, which is ED. As you know, ED is a segment, then you can use the segment addition postulate. In this case, EC, to find ED, that will be EC plus CD. That will give you that. Right? So in this case, in order to solve this problem out, your tangent is 5, you're going to square 5. That will be 5 squared. E is equal to EC, in this case EC is X, times ED. Remember, ED is a segment addition. That will be EC plus CD. EC is X and CD is 4. And be aware, when you're working this kind of problems, they are going to create quadratic equation where we will have to use either completing the square factorization or quadratic formula. So this is from algebra 1. So in this case, when you square 5, it's going to give you 25. Then you use this property, that's going to give you x squared. And x times 4 is 4x. Now, as you can see, you have a quadratic formula. So, like I did earlier, so I'm going to use many concepts for you. I'm going to use completing the square. Remember, completing the square, you take the b term, which is 4. You divide by 2, then you square that. Then you're going to add that to this side. If you take 4, you divide it by 2 is 2. You take 2, you square it. And it's going to give you a perfect square trinomial. You add 4 on this side. If you add 4 on this side, you have to add 4 on that side. Therefore, you will have 29 is equal to x squared plus 4x plus 4. This becomes a perfect square trinomial. Now you're going to rewrite it as a binomial. And if you don't see what's going on, therefore I have already created a lesson on completing the square quadratic formula. Therefore you will have to revisit those lessons. So you will have 29 is equal to x plus 2 squared. And some of you are going to ask question, where's the 4? Where's the 4 and the 4x? So when you expand that by using 4 method, it will be there. In this case, you take square root of each side. Then you will have x plus 2 is equal plus or minus root of 29. And in order to solve for x, you will have to subtract 2 from each side. And your outcome will be x is equal to negative 2 plus or minus root of 29. If you will add to change that to decimal, then you can do so. Other than that, that will be the solution to this problem. Alright, like I said, I can use multiple steps to solve for that. We could have this quadratic formula of completing this, we just did completing this square. So if you use factorization. In this case, it's not going to work. In this case, we are going to use quadratic formula, which is a concept from Algebra 1. Then you will have to revisit those concepts again. So no problem. So that's what we're here for. We're going to use as many options as possible to when we're dealing with this type of problem. Alright. So if we are going to use quadratic formula, from there here, when we have this, when we export that was x squared, alright, plus 4x, and you're gonna subtract the 25 on the other side and let it equal to 0. Then that will be what we will end up with. In this case, then to use quadratic formula, it's a formula. So if you watch the videos on completing the square method, you will see where we derive with quadratic formula by using the completing the square method. So in this case we will have this equation. A is 1, A is the leading coefficient, there's an invisible 1 here. In this case, A is 1, B is 4, and C is negative 25. And the quadratic formula is x equal minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. It's a formula. You will have to replace those parameters, then you use PEMDAS. Other operation will set you free from there. In this case, you will have x equal negative b, that will be negative 4, plus or minus square root of, you take 4, you square it, minus 4 times 1 times negative 25 minus y. You see, everything is over 2 times 1. And in this case, you continue the process. You are supposed to expect it to get the same outcome. You will have, when you square, that will give you 16. That will give you 4, that will be plus 100 and plus 100. Everything is over 2. Then as you can see, you will have minus 4 plus or minus square root of 116. Everything is over 2. So now you know 16. This you will have to work this out to see if there's any perfect square inside of that. You will do factor 3. We do that when we are using distance formula of Pythagorean theorem. That would be 2 times 58. 58 is 2 times 29. Therefore, this will give you 4 times 29. That will give you 116. So we're going to change that. We will have x equal negative 4 plus or minus. Alright. So we're gonna need space. So in this case, so that the reason you have to know as many options as possible. Therefore, it would have been easier when we did the completing the square. So you will end up with x equal minus 4 plus or minus 4 times 29. Everything is over 2. Right? Then you will end up with x equal minus 4 plus or minus. Then you take square root of 4. Square root of 4 is 2. The 29, there's nothing you can do about it. Then this stays and that. Then you're going to work this out. Those things have 2 in common. Then you'll have x equal negative 2 plus or minus. Because when you cancel that, this is going to give you square root of 29. So that will be the same outcome in a different method. That's the reason you have to know as many methods as possible in order to do those problems. So that's the beauty of math. Alright, that was one. So we're gonna do the other equation here. We have AB, which is the tangent. We're gonna square that. So this telling you have to square the tangent. Therefore, you will have 12 squared is equal to BC, all right, times BD. That's what you will have to do, and that's how the problem will be set. Let's do this, and you will see how beautiful those thing is. So once you can do this, you will see that how powerful math is. In this case, our equation will be AB squared, then you will have 12 squared. You take 12, you squared is equal to BC, which is X, times BD, right? And BD will be X plus 10. So that's your equation. And as you can see, it's going to generate a quadratic equation again. Then you will have 144 is equal to X squared plus 10x. So we're going to use both method again, or you take this number, which is 10, you divide by 2, and you square, that will give you 5, and then when you square 5, this will give you 25. Then you add 25 on that side, you have to add 25 on that side. So this will give you 169 is equal x squared plus 10x plus 25. Then you will have 169, write it as a binomial, that will be 5 squared. Then you have to take the square root of each side, and you will have plus or minus 13 is equal to x plus 5. In order to solve for x, you will have to subtract 5 from each side. If you have x plus 5 is equal plus or minus 13, then you subtract 5 from each side. Then you will have x equal minus 5 plus or minus 13. So you will either have negative 5, your first option is negative 5 plus 13. The negative 5 plus 13 will give you 8. The other option is negative 5 minus 13. In this case, x will be negative 18. Those are your possible answers. However, when you have two answers, since you're looking with length, you don't want your length to be negative, we will have to reject that. In this case, we only keep where x is positive 8. That's one of the options. The other option, we could have used either factoring or completing the square. We did just completing the square or quadratic formula. Then we're going to use quadratic formula. You will see that you will end up with the same outcome. Your goal is to get the equation and use whatever method that is best for you. So if we were to use quadratic formula, we're going to take this part here where we did not complete the square, or we come here, that will give you 144. 144 is equal to x squared plus 10x. In this case, we want this side to equal to 0. When using the quadratic formula, you subtract 144 from each side, then you subtract 144. Then you'll have x squared plus 10x minus 144 is equal to 0. You could have either use factor or quadratic formula. Factor does not use all the time, but completing this square and quadratic formula use all the time. That is when I'm going to use quadratic formula. Maybe quadratic formula is x equal minus b plus or minus square root of b squared minus 4ac. Make sure you remember this formula over 2a. Then this is what we are going to use. In this case, a is 1, coefficient of that number, b is 10, and c is negative 144. Right? In this case, we will have x equal negative 10 plus or minus root 10 squared minus 4 times 1 times negative 144, and over 2 times 1. So that's how you set it up, and from there on you are expected to use PEMDAS so you can get home free. Alright, now we're gonna erase that, and you will end up with, you evaluate that x equal negative 10. When you square this, that will give you 100. Right, you multiply to negative, you will have 144 times 4 to negative going to become positive. That will give you 16. 16 again, that will give you 17. Okay, 1, that will give you 576. 5 plus 576. And everything is over 2. And then you'll have x equal minus 10 plus or minus root of 676 over 2. I mean, the square root of 676 is 26, if I'm not mistaken. Then you will end up with x equal negative 10 plus or minus, and let's find help in when you take square root of 676. I believe it's 26, so I'm going to go with my gut feeling. Alright, then you end up to that. Then you simplify this. Everything can be simplified by 2. That will give you negative 5 plus or minus 13. Then that's our outcome, and like you said earlier, we either have negative 5 plus 13, that will give you 8, or you either have negative 5 minus 13, that will give you negative 18. In this case, you don't want the negative 1, and you keep the positive 1. Alright, let's take a break, then we come back later. I'm back, continuing our lesson. And when we have a secant and a tangent, remember that you always square the tangent. In this case, the tangent is ED, so your equation will be ED squared. In this case, ED is 8. You will have to square 8. Is equal to the external part of the tangent. The external part is EB, so time EB. In this case, EB is x, we replace x, time the entire secant, which is EC. Now be careful. Now to find EC has to do with segment addition postulate. EC is equal to EB plus BC. So in this case, we know that EB is x, then you will have to replace x plus BC, which is 12. So that will be your equation. Now your equation is complete. Then you will do this with the property, x squared plus 12x, and 8 squared is 64. Once again, it generates a quadratic equation, so we will use both options or the other third option, which is factorization. So we're going to use completing the square and quadratic formula because those two work all the time. So I'm going to take 12 divided by 2. If I take 12, I divide by 2 and square, that will give me 6. When I square 6, that will give me 36. That's what I have to add, so I can have a perfect square trinomial, and I have to add 36 on the other side. So I will end up 36 plus 64 is 100. Then I will end up with x squared plus 12x plus 36. Then I'm going to rewrite that as a binomial. Then I will have x plus 6 squared is equal to 100. Then my next step in the process is to take the square root of each side. Then when I take the square root of each side, then I will be in business. So when I take the square root of this, then I will end up with x plus 6 is equal plus or minus 10. Right? In order to solve for x, I will have to subtract 6 on each side. And I will have x equal negative 6 plus or minus 10. This will give me the two outcome. So to simplify that, my first outcome is x is equal to minus 6 plus 10. That one chose. And that will give me 4. 4 is one of my possible answers. And the other outcome will be either minus 6 minus 10. That will be negative 16. As you can see that I am looking for distance, for length, cannot be negative. I will have to reject that, and I only keep the positive 4. So if you want to justify that, when x is 4, there you go, what will happen? If I take 8 as square root, that will give me 64, and that will be 4 times 4 plus 12 is 16. Both has to be equal. Then you will have 8 squared is 64, 4 times 16 is 64. That's how you check those babies. Alright? And like we promised, we're going to use either a quadratic formula or complete least square. So we just solved that by using complete least square. Then we're going to revisit quadratic formula and give you the other option. So we remember that. So your original equation was x squared. Quadratic formula, we find x squared plus, that was 12x. That was equal to 64. So in order to complete this square, you will have to also let this side equal to 0, then you will end up with that. So you will have x squared plus 12x minus 64 is equal to 0. That can be factored, but I'm not going to factor it, so we're going to still use quadratic formula. And in this case, a is 1, b is 12, and c is negative 64. Then we can go enter this in the quadratic formula. By now you should know what it is. It is x equal negative b plus or minus square root of b squared minus 4ac over 2a. Remember that I have lesson already created on this. You can go do your due diligence and log those lessons. That will be minus 12 plus or minus, you take 12 squared minus 4 times 1 times negative 64, which is c. Everything is over 2 times 1. Then everything else has to do with permanence. We'll have x equal negative 12. When you take 12 to square it, I'll give you square root of 144. Excuse me. Then you take 64 times 4. I'll give you 16, carry 1, 24, 25, I'll give you 256, I'll give you plus 256. Everything is over 2. Then as you, like I said earlier, everything has to do with order of operation. You will have negative 12 plus or minus, I'll give you 400. Everything is over 2. And need some middle space, and we're going to clean some of our mess earlier. Everything is about order of operation. Then you will have x equal negative 12. Square root of 400 is 20 over 2. Everything is divisible by 2. Then that will give you x equal, I'll give you negative 6 plus or minus 10. That will be your two solutions. As you can see, the answer does not change, and to find your final outcome, that will be negative 6 plus 10, which is 4. The other alternative is negative 6 minus 10, which is negative 6. As you know that we don't need the negative, we only keep the positive 1. So let's go on the next problem. Then we can call it a quit on this lesson. As long as you follow those guidelines, those theorems, you're gonna get home free. So that's the objective of those lessons and property of circle, and that the reason I keep using completing the square, which is very essential when you're dealing with circle, equation of circle. You will have to do that. So this is the last question on this. So remember, AB is your tangent, so you will have to square your tangent according to the theorem. So in this case is 11. We're going to take 11, we square it, AB squared. You have to square the tangent. You will always equal to the external part of the secant. The external part in this case is x. Then that will be x, which is represented by AC. Then you're going to time it by the entire secant. Now the entire secant is the segment addition, which is AC plus CD. So that's what we're going to multiply it by. We're going to multiply it by AD. Alright? So as you can see, AC is x, that will be x plus CD, which is 9. Then that will be your equation. You will end up with 11 squared, which is 121. Then you do discrete property, that will give you x squared plus 9x. Now we're going to use completing this square. Now you need to start paying attention because it's going to be very complicated, because you're going to end up with a fraction. So you're going to take 9, you divide by 2, do not change that to decimal. When you square that, that's going to give you 81 over 4. And that's what you add here, 81 over 4. And you have to do the same thing on the other side, 81 over 4. Now the only thing you have to combine that as a one fraction, right? As one unit fraction. Right? So let's start clear some of those mess. In this case, we're going to work this side out. We want to have the same denominator. This is already okay. We're going to multiply this by 4, and you're going to multiply this by 4 so you can keep it quiet. So this part, we're going to rewrite it as a trinomial. That will be 9 over 2 squared. And the only thing we have to simplify in that will give you 81 over 4 plus your denominator will be over 4. Then we will take 121 multiplied by 4 to get the denominator. That will give you 4. That will give you 8. That will give you 484. Alright? 484. That will be 484. Then you will end up with x plus 9 over 2 squared. Then since those who have the same denominator, you can add them. Then you will have 484 plus 81. This will give you 516. That will give you 565. 565. Then you have to take square root. Then you will have x plus 9 over 2 plus or minus. This is going to be over 2. So this we're going to see how can we factor that. We're going to do factor 3, 565. Let's see by 5. And on the calculator, if you take 565 divided by 5, that would be 1 time 26. That will be 1 time. I'll give you 113. Is there anything you can do with 113? Not quite. In this case, that will give you 565. Then you will have x equal 9/2 plus or minus 565 over 2, and that will be your final product unless you change that to decimal. That was Mr. This is in another one. Enjoy and have a nice one. Take care.